Quadratic relations of the form y equals a x minus r x minus s. This is the factored form of a quadratic relation, and we're gonna go over that. So let's just do a little recall. So let's recall that the midpoint of a line segment is just the average of the x's, comma, the average of the y's, and that's going to give you an ordered pair. Okay. And then a little recall from grade 9. So in order to find the x-intercept, what we're going to do is we're going to sub y equals 0. So let's go ahead and find the x-intercept of these two lines below. So in order to find the x-intercept, y equals 0. So we sub 0 in for y, and we're left with 3x plus 15. Bring over this 3x, we get negative 3x equals 15, and then divide both sides by negative 3. We get x equals negative 5, and that's just algebra. So our x-intercept is negative 5, comma, 0. Okay, one more practice. So to find the x-intercept, we sub y equals 0. So we sub this y equals 0, and that y term now just goes away. Okay, we get 8x. Let's bring this negative 16 over. We get positive 16. Divide both sides by 8, and we get x equals 2. So our x-intercept is 2, 0. We're going to work with the same concept because in all equations, it's going to be the same idea. To find the x-intercept, we still have to sub in y equals 0, regardless of whether we're working with a linear relation or a quadratic relation. So that's what we're going to take a look at now. Okay, so let's just go over a couple things. So the factored form of a quadratic equation is in this form right here. Okay, so we have basically the a value and then two factors, x plus or x minus something, and then x plus or x minus something. And the x-intercepts are indeed, like see this r? That's exactly what the x-intercept is, and this s. But only when it's in the form x with no coefficient minus r, or x minus s. Only when it's in that form. The axis of symmetry. So as a recap, the axis of symmetry is a vertical line in the form x equals x-intercept. Okay? And all the points on this line here, on this vertical line, share the same x-coordinate. And this line passes through the midpoint of R and S. And it passes through the vertex. So if we had a Cartesian equation or a Cartesian plane here, and we had the R and the S, which would be like the x-intercepts, that would be on the same horizontal. So yes, this vertical line would pass through the midpoint of that. Okay, please note corresponding points are the same distance from the axis of symmetry. Okay, so if we take a look here, and I'm just drawing two arrows in, wherever the points are on like the same horizontal, they're going to be the same distance from the axis of symmetry. And that's why we find the average of those 2 points on the horizontal, or the average of the x-intercepts. That's to find the middle point. Okay, the vertex again in the form h comma k. So in this equation, we can't see an h comma k, but there still is a vertex. So to find the y-coordinate of the vertex, what we're going to do is we're going to sub the x-coordinate of the vertex, which is here, into the original equation, and this is going to come up just algebraically. Okay, and then the direction of opening. This a value is the same for standard form, for factored form, and for vertex form of a quadratic. So if a is positive, the parabola opens up. If a is negative, parabola opens down. Okay. And then what we're going to work on is to sketch the graph of a quadratic in factored form. What we have to do is we have to actually find the x-intercepts, and then we're going to have to find the axis of symmetry, we're going to use that axis of symmetry, which is going to be like our h value, to find the y coordinate of the vertex. Then we can sketch it. So we would be using the x-intercepts and the vertex, which gives us, like, say, 3 points like this, and then we're going to graph the parabola through those points. So let's go ahead and do this hands-on. Okay, so for the parabola y equals 2, x plus 1, x minus 7, find the following, and then graph the relation. So first, let's actually find the x-intercepts or the zeros. So we have this equation right here. So let's take x plus 1. Actually, let's go through this the longer way. I'm going to rewrite this. Okay? In order to find the x-intercepts, we're going to sub in y equals 0. So what we're looking for is we're looking for a number or two numbers that make this equation equal to 0. So in order for this side of the equation to equal 0, either this has to equal 0, which is never going to happen because 2 can't equal 0, or this has to equal 0, which is x plus 1 has to equal 0, or x minus 7 has to equal 0. So in this case, if we bring over the 1, if x equals negative 1, then this factor equals 0, and 0 times anything will equal 0. So then that would work. Or bring over that negative 7, x equals 7. So if we subbed in 7 here, 7 minus 7, this factor would equal 0. Times anything times anything equals 0. So our two zeros are negative 1 and 7. Let's just plot those right away. Okay? What's the equation of the axis of symmetry? So we're going to go minus 1 plus 7 divided by 2. We're going to average them out. So I get 6 over 2, which is 3. So we're going to go down to 3, and we're going to say x equals 3, because that's our equation of our axis of symmetry. Now our vertex. We have the full equation. So what we want to do is we want to sub in this x equals 3 and solve for y. So let's go 3 plus 1, 3 minus 7. So I get 2 times 4 times negative 4. Well, 4 times negative 4 is negative 16, and that times 2 is negative 32. So our vertex is 3, our axis of symmetry, comma, negative 32. And we just found this by simply subbing in the 3. We know the x value of the vertex, which is h, and we just sub it in and find the y. So this is down here. Direction of opening, well, leading coefficient's 2, so a equals 2, so therefore it opens up, which makes sense using these 3 points. And there's our graph. Okay, example 2. So we have another parabola, and we have to find the following. So let's first find the x-intercepts of this parabola. So I'm going to rewrite it. Y equals negative 2, x minus 4, x plus 2. So we know to find the x-intercepts, we have to sub in y equals 0. So we have to find values that will make this side of the equation equal to 0. So again, because this is in factored form, everything on the right-hand side here is multiplied. Negative 2 can never equal 0. So let's find when x minus 4 equals 0. Bring over that negative 4, we get when x equals 4. Let's find when x plus 2 equals 0. Bring over that 2 when x equals negative 2. So those are our two x-intercepts. So we can go ahead and graph those on our x-axis, 4 and negative 2. Now the equation of the axis of symmetry, we're going to take 4 and we're going to add negative 2, and we're going to divide it by 2, which I get 2 over 2 is 1. So the equation of our axis of symmetry is x equals 1. When I plot that, I just make sure it looks right. So yeah, 1 looks like 1, 2, 3, 1, 2, 3. 3 units away from both. So we need to decide, or we need to calculate the vertex. So we know the axis is symmetry, so we know the h value is 1. So just sub 1 back into the original, and let's just find the y. So 1 minus 4, and then we have 1 plus 2. Okay, so we have negative 2. I get 1 minus 4 is negative 3. 1 plus 2 is 3. 3 times negative 3 is going to be negative 9. 9 is 18. My h comma k is 1 comma 18. So I can go ahead and graph that, because now we have 3 points. And direction of opening, well, a equals negative 2, so we know that this opens down, so this graph makes sense. All right. Couple activities. So let's fill in the chart for each equation. So the equation in factored form, this one's already in factored form, and this one's already in factored form. But this one, let's just take a look here at this x. We can write this as negative 3, x minus 0, and then x minus, or x plus 6. So this puts it a little bit more into factored form. Okay, what are the zeros? Well, we can solve for these. X minus 6 equals 0. Bring that over. X equals 6. That's one x-intercept. And then when does x plus 2 equal 0? Well, when x equals negative 2. So we just bring that over. I'm going to go down now. Equation of the axis is symmetry. It's always in the form x equals u6 plus negative 2 over 2. And 4 over 2, and I get 2. The coordinates of the vertex. So we have the equation of the axis of symmetry. Let's just sub in 2 minus 6, 2 plus 2. And if you notice, this one's negative 4 and this one's 4. These are always repeated because what we're doing is we're using the axis of symmetry, which is equidistant from both zeros. So it makes sense that these two numbers are going to be the same distance away. So I get negative 64. So our vertex occurs at 2 comma negative 64. Okay, second equation. So this is the a value. We don't want anything to do with that right now. We want to find the zeros. So we're going to set both of these factors equal to 0. 1/2 is never going to equal 0, but this bracket can and this bracket can. So x equals negative 8, that's going to be one of our zeros. And when x minus 4 equals 0, x equals 4. So we're going to go negative 8 plus 4 divided by 2, which is negative 4 divided by 2, and I get negative 2. So the equation of the axis of symmetry is negative 2, which is halfway between negative 8 and 4. Now let's go negative 2 plus 8, negative 2 minus 4. 1/2, 6 times negative 6. So this is going to be a half of negative 36, which I think is 18? 18. Negative 18. So our vertex is going to be negative 2 comma negative 18. Okay, last one, zeros. So x minus 0, whenever we have this like negative 3x, and I'm actually going to do it from here. So negative 3x equals 0. Every time we see an x value, we're going to have an x-intercept. So a lot of people have an issue between the leading coefficient being a number such as 1/2 and the leading coefficient being a number and a variable, which is like negative 3x. So as long as it has this x, there's going to be an x-intercept. If we divide both sides by negative 3, x is now isolated. And what's 0 divided by negative 3? Well, it's just 0. Okay, then we have x plus 6 equals 0. Bring that over. X equals negative 6. Okay, now let's average those two out. 0 plus negative 6 over 2. negative 6 over 2, which is negative 3. So the coordinates of the vertex, let's sub those straight in. We're going to get negative 3, negative 3, negative 3 plus 6. So negative 3 times negative 3 is 9. Negative 3 plus 6 is 3. And I get 27. So the coordinates of the vertex are negative 3, 27. So just an activity just to follow up. Okay, example 4. The zeros of a parabola, I don't know if there's an E in this. I don't know. Are negative 3 and 5. So we can even put like R equals negative 3 and S equals 5. The parabola crosses the y-axis at negative 75. So if it's laying on the y-axis, that means it's laying right here. That means it's 0, negative 75. That's going to be the y-intercept. But it also gives us a point in the form x, y. So first, what's the equation of the quadratic relation in factored form? So the exact same process as like the vertex form, but we're just using factored form this time. So let's sub in R and S first, just to walk through the steps. So x minus negative 3 and x minus 5. Now we're going to sub in 0, negative 75. So negative 75 equals A, 0 plus 3, 0 minus 5. So negative 75 equals A, 3, negative 5. So negative 75 equals negative 15A. And then we're going to divide both sides by negative 15. And we're going to get A equals 5. Okay. So what's the equation? Let's say the equation is y equals, we have A, which is 5, x plus 3, x minus 5. X plus 3, x minus 5. That is our equation. And this is not the vertex, remember. So the vertex could be, let's see, 3 and 5. It's going to be somewhere over here, a little bit more. And what are the coordinates of the vertex? Well, we know we have to average out negative 3 and 5, which gives me 2 over 2, which gives me 1. And then we just have to sub 1 right back into the equation. So y equals 5, 1 plus 3, 1 minus 5. We want to know the y, the optimal value, when the x value is 1. So 4 times negative 4 is negative 16. 5 times 16, I get 80. So negative 80. So the h, k is 1, negative 80. And that's our vertex. Okay, same idea for number 5. Determine an equation in factored form of the quadratic relation with 5 and 0 as the x-intercepts and a minimum value of negative 10. So we know that this is going to be our k, and these are going to be our r and s. So if we have y equals a, x minus r, x minus s, we can sub in, so far, we can sub in 5 and 0. Let's go minus 0. I always put the 0 first because I'll show you. And then this is positive 5, so minus 5. So we know that because these are x-intercepts, 5 and 0, the axis of symmetry, which is our h value, is going to lie right between them. So we can go ahead and average out 5 plus 0 divided by 2, and it's 5 over 2, or simply 2.5. So we know that our h value is 2.5. So along with the minimum value of -10, our vertex h comma k, we're going to know is -10, 2.5 comma -10. And even though this is our vertex and we could technically put it into vertex form, we're not asked to. We're asked to put it into factored form. So we can just simply use this as one of the points on our parabola that we know. So -10 equals a. Let's go 2.5 minus 0 and 2.5 minus 5. Okay? And again, because we use the two x-intercepts and we're using the axis of symmetry, which is the vertex, which is equidistant, we're going to get 2.5 and then -2.5, which gives us 6.25. So -10 equals 6.25 a. Divide both sides by 6.25. We get 1.6 or 8 over 5. So a equals 1.6 or it equals 8 over 5. Okay, so this is a vertical stretch by a factor of 8 over 5 or 1.6. So the equation is going to be 8 over 5. But see this x minus 0? We can just put x and then bracket x minus 5. Okay, so now determine an equation in factored form for the following parabolas. So if we want this in factored form, let's just write out y equals a x minus r x minus x. Okay, so our zeros we can identify as 0 and 4. So 0, 0 and 4, 0. Then what we're going to use is we're going to use this point right here. It's identified 7, 7. So let's sub in everything at once. The x and the y is 7, 7. Okay. And then 1, 0 is 0, and then 1, 0 is 4. And let's solve for a. 7 equals, this is 7, this is 3, this is 21a. And when we divide both sides by 21, we get a equals 1/3. Okay, which is positive, and this is a compression by a third. We can see this is a little thicker, a little wider than the original. So our equation is y equals 1/3 x, because remember it's x plus 0, and then x minus 4. And that is the equation of this parabola. Okay, next one. Let's identify the two x-intercepts, which I get -5, and I get 5. Oh no, I get 7. So 7, 0, and -5, 0. And the x, y that we're going to use is going to be 9, -5. Okay, so let's write out the equation in factored form, just the general equation, and then let's sub everything in. So the y that we're using is -5, and the x's that we're using is 9, obviously for both of them. So this one kind of stumps students sometimes. Both of these x's are the same. So sub in 9 for both. And then we get -5, so we'll do +5, and then -7. So now let's solve for a. 9 plus 5 is 14. 9 minus 7 is 2. And we get 28a. Let's divide both sides by 28. Those go away. We get a equals -5 over 28. So our equation is -5 over 28, which is a vertical compression by a factor of 5 over 28, and it's a reflection because it's negative, and that makes sense because it's opening down. And we get x plus 5, x minus 7. A soccer ball is kicked from a point 23 meters to the left of a halfway line. So this this y-axis is going to be the halfway line. So it's 23 meters to the left, which is going to be negative 23, comma 0. And lands at a point 17 meters to the right of the halfway line. So let's go 17, comma 0. Okay. It reaches the max height of 10 during the parabolic flight. So it's going to go up and then down. And the max is going to be, the max is going to be 10. So it's going to be somewhere here. I just don't know the halfway point. Okay, sketch a graph to show the flight of the soccer ball if the halfway line passes through the origin. So yeah, the halfway line is here, which is like the y-axis. And now what we're going to do is, you know what, let's go ahead and like solve for the midpoint. So negative 23 plus 17, and we're going to find the midpoint of that. So I get negative 6 over 2, so I get negative 3. So at negative 3, which is right here, this is the axis of symmetry. So the vertex is going to occur at negative 3, comma 10, because that's the max height. So max height. Now we have three points on the equation. So now let's determine the equation in factored form to represent the path of the soccer ball. So y equals a, x minus r, x minus s. Okay. Let's sub in 10, negative 3 for x and y. Okay. And let's sub in negative 23, which turns to a positive 23, double negative, and 17, which stays as the negative 17. Okay, negative 3 plus 23, I get 20. And then negative 3 minus 17, I get negative 20. So I get 10 equals negative 400, A. So let's divide both sides by negative 400. Okay. Those go away. We get A equals negative 1 over 40. Okay. So therefore, the equation for the path of the soccer ball is negative 1 over 40, x plus 23, which means one of our zeros is negative 23, and then x minus 17, which means one of our zeros or x-intercepts is positive 17. Okay, the a value is negative, and the path of the soccer ball does open down, so that's positive. And then what we could do for like one extra step is that we can say that like right here and here, the ball's not going to go through the ground, right? So we can actually restrict this on the domain, negative 23 to 17. Because before this, it doesn't exist because they haven't kicked it yet. And after this, it may bounce and show something a little bit different. So it's not going to be continuation, because the continuation would go through the x-axis or go through the ground, so it won't be continuation. It'll represent a different graph. So we can restrict the domain, and that makes sense.